Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir. Today we will be solving problems on type 3 particular integrals from higher order differential equations. See, in the previous videos we did type 1 and type 2. Let me do a small recap. In type 1, yp was e raised to ax divided by f of t, wherein we replace denominator or reduced by a. In type 2, the right hand side or yp was sin x or cos x upon f of d, wherein we replace only in the denominator d square by minus a square. Okay, now see, type 1 RHS is e raised to x. Type 2 RHS is sin x or cos x because the particular integral depends upon the RHS. Now, type 1 exponential, type 2 trigonometric. The type 3 is here, the RHS will be polynomial or an simple form, an algebraic expression like x squared plus 2x plus 2 or say 12x squared so on. Okay, so here yp is equal to polynomial upon f of t. Fine. See, in your VT syllabus, actually there are 5 types. But since they have made the syllabus now very easy, you have only 3 types. Okay, so we will go according to the VT syllabus. So today we will do type 3 and I will explain this in my usual simple systematic way so that each one of you can understand. So please stay till the end and also no skipping. And if you are new to this channel or you have been watching my videos and you like the way I teach, then please do share this with your friends and classmates as much as possible, and also to please don't forget to subscribe. So let me introduce you to type 3. The type 3 is here f of dy equals phi of x. Okay, that means that implies the particular integral yp is equal to phi of x upon whole divided by f of t. Here, as I told you already, phi of x is nothing but a polynomial. See, what's a polynomial? Polynomial in simple ways is an algebraic expression. See, type 1 was exponential, type 2 was trigonometric, now type 3 is algebra. That means, example say x cube plus 2x square plus 3x plus 1, or say 12x square plus 2x, or say 5x square, etc. Whatever it can be. Okay, it is basically algebraic expression. Now, finding the particular integral for such a type, there are 2 methods. So, as per the VT syllabus, I will go the most easiest way, it is a long division method. So, follow it carefully. Now, see, here the particular integral or the pi is nothing but, or yp is nothing but quotient of what? Quotient of phi of x whole divided by f of d. That is, I take this as what? Numerator upon denominator. I am denoting numerator as NR, denominator as DR. And here the numerator is in descending order, big to small. I tell you that descending order whole divided by the denominator is in ascending order. What order? Ascending order. See, descending order of the algebraic expression like x cube, x square, x and constant. This denominator ascending order of d's like constant, then d, then d square, then d cube, so on. That's all. So divide it, get the quotient, and that quotient is nothing but the particular integral. Very easy. So we'll make it more easy and I'll help you understand in a very clear way by solving the problems. So let's move on to the problems now. Let's start with this problem. Let's say y double dash, I take the problem as y double dash plus 3y dash plus 2y equals to, okay, let's take 12x square. Important problems which has been asked in the examination. So what is that? Y double dash plus 3y plus 2y is equal to 12x square. Now how to solve this? So first, what is that? The complementary factor always. So y double dash is d square plus 3d plus 2 into y equals 12x square. Now we write the auxiliary equation m square plus 3m plus 2 is equal to 0. Use a calculator, or this is a very simple equation. Okay. So we can write m is equal to here minus 1 and minus 2. So we know the roots here. After finding the roots, the complementary factor will be c1 e raised to minus x plus c2 e raised to minus 2x. Done? So till here underlined, you get the complementary factor. The next main thing is finding the particular integral for this type 3. That means I have the yp is equal to 12x square whole divided by d square plus 3d plus 2. Now as I told you, we will employ the log division method. I will solve here. What was that? Refer the theory again. The numerator descending order big to small. So only 12x square keep as it is. Denominator in ascending order small to big in powers of d. So first is constant plus 3d plus d square. Now let's divide it. Simple division. Okay. So we have here I write 12x square whole divided by, what is that? 2 plus 3d plus d square. Fine. Okay. Now, so here, how we divide? It's a very simple division. See, I'll tell the simple way. 6 divided by 2. What you do? 6 by 2. 2 3s are 6. That's all. Simple logic here is, listen to me carefully. What I say, please don't skip. Listen carefully, lend your ears to me. See, it's very important steps here. Here, people get confused how to divide. Again, I repeat. First term by first term, always. You need to make this first term 0. So, to make that first term by first term, 12x square by 2. 12x square divided by 2. What is that? 6x square. Now, simply keep on multiplying. 2 into 6x square is 12x square. 3d into 6x square. So, I do it here. Okay. 3d into 6x square. 3d into 6x square means 3 into d means what? Into d means differentiation. Again, into d means differentiate. So, difference 6x square is 12x. That will be 36x. So, plus 36x. Again, d square of 6x square. D square into 6x square will be d of differentiate 2 times. Differentiate 6x square is 12x. Again, d of 12x. Again, differentiation of 12x is 12. That's it. Plus 12. Okay. Now, minus, simple mathematics. This cancels. We have minus 36x minus 12. Now, again, listen. First term by first term. You have to make minus 36x equal to 0. We made first 12x square equal to 0, divide on first term. Again makes minus 36x equal to 0, dividing by the first term. What's that? 2. So, minus 36x divided by 2 is how much? Minus 18x. Am I right? It is what? Minus 18x. So, okay. Again, 2 into minus 18x is minus, I should get the same term. Again, 3d into minus 18x. See, 3d into minus 18x will be only one time differentiation. Differentiation of 18x is 18. So, 3 18s are 3 is 24 minus 54. So, we have here minus 54. Next, again, d square of minus 18x. See, it will be 0. Why? Because see, if you tell d square of minus 18x, so that will be d of minus 18, and that is nothing but 0 because 18 is a constant. That's it. As simple as that. Now, see this again plus, and this plus cancels. Now, 54 minus 12 will be 42. Now, the last term remaining is 42. Again, make 42 equal to 0. How? First term by the first term. 42 divided by, who is the first term here? 2 always. 42 by 2 is 21. So, plus we have 21. Now, this factor, what is having is nothing but the particular integral. That's it. Therefore, we have yp is equal to 6x square minus 18x plus 21. Therefore, the solution is CF plus PI. So, we have the CF as C1 e raised to minus x plus C2 e raised to minus 2x plus 6x square minus 18x plus 21. Beautiful. That's it. That's the solution. This is how we solve type number 3. Let's move on to the next question here. A slightly different question. D square plus d into y is equal to x square plus t plus 4. So first, let's find the complementary factor. The auxiliary equation is m square plus m is equal to 0. So m is, there should be 2 roots. So m into m plus 1 is 0. Very simple solution. So 1 is m is equal to 0 and m is equal to what? Minus 1. Roots are m is equal to 0, minus 1, 2 roots. Therefore, for these 2 roots, the complementary factor will be C1 e raised to 0x plus C2 e raised to minus x. Am I right? Fine. Or the CF is C1 plus C2 e raised to minus x. That's it. Okay. So, underline this. We have found the CF. Now, the next part is the particular integral. Okay. So, we have yp is equal to x square plus 2x plus 4 whole divided by d square plus t. Now, I will rewrite this as you know, since we are doing the long division method, the numerator in descending order big to small and the denominator in ascending small to big. Big to small, small to big. Okay. Now, this is as usual, correct, x square plus 2x plus 4, x square, x and 4. Small to big, descending. But the denominator, let's write it here, d square by d. So, d will come first, there is no constant, plus d square. Now, we need to divide this, find the particular integral, find the quotient using the long division method. Okay, right here, x square plus 2x plus 4 whole divided by d plus d square. Okay, now, let's solve this. So, what I told you, the logic here, very simple logic, always follow my words, follow what the step I do, it is very easy for you. First term by first term, I want to make this x square 0 first. So, what is the first term d here? So, first term divided by first term, as simple as that. The thing, complicated. What? I want to make x square 0 first. So, how to make it? First term by first term, simple. Okay, I am explaining very simple words. So, x square by d. So, here what will come? X square whole divided by d. Now tell me what? There is no number, there is d here. No. I hope you might be recalling it. Upon d means what? Integration. Into d means differentiate, upon d means integrate, as simple as that. So, this will be integration of x square. And as the integration is very simple, it's a very standard integration. Integration of x is to n is x is to n plus 1 by n plus 1. Fine. So, integration x cube is what? X square is x cube by 3. X raised to 2 plus 1 by 2 plus 1. So, I have here x cube by 3. Fine. That means obviously d into x cube by 3 is, it will automatically become x square. Now, d square into x cube by 3 will be d of 2 times d square means 2 times differentiate. First differentiation is 3x square whole divided by 3. 3 cancels. Again, d of x square, differentiation of x square is 2x. Fine. So, plus 2x. Done. Okay, next again, nothing is there. So, let's cancel it here, minus, minus. So, this both cancels. What remains? 0 plus 0. This will be 4 plus 4. Okay. Now, what's remaining? 4. So, how to remove this 4? Again, what remains? The first term divided by first term. 4 divided by d. So, 4 by d is equal to integration of 4 and 4 dx, or what is the integration of 4 dx? 4 as it is, integration of 1 is x. So, integration of 1 is x. So, this will be plus 4x. So, this will be 4 cancels 0. That means what I am getting here is the particular integral. That's it. Therefore, the particular integral yp is equal to x cube by 3 plus 4x. Fine. Therefore, the solution y is equal to cf plus py or c1 plus c2 e raised to minus x plus x cube by 3 plus 4x. That's the solution, how we obtain it. That's all. This question had been asked in the examination once. Okay. Please watch it carefully and practice it. Again, into d means what? Differentiate, upon d means integrate. That's it. That's all in today's class. If you have any doubts or queries, or if you want me to solve any other problem, then please drop a comment below. Remember, this is the third and the final type for the V2 syllabus. In the next video, we will discuss more tricky mixed type of problem that is involving all the type 1, type 2 and type 3, which are frequently asked in the V2 examination. So please don't miss that one. Till then, study hard, practice each and every problem, watch the videos repeatedly till you understand it. So best of luck. See you in the next video. Bye.